Hey YouTube, in this video I'm going to show you how I installed this inverter under the passenger seat in my camper van in order to charge this power bank while I'm driving. Now I've already shared information about my battery bank and solar panel installations as the main electrical system for my camper van. I'll put a link to that video here and down in the description so you can watch that video if you like. But in this video, we'll just focus on the details of how I installed the inverter here under the front passenger seat to complete that system. So what is an inverter? An inverter is a device that takes electrical power from the 12-volt system in your vehicle and converts it into 120-volt AC power like you have in your house. I'll then use this to charge my battery bank while I'm driving. Now there are two big factors you should consider when you select an inverter for your camper van. First, I suggest you get an inverter with pure sine wave output. What does that mean? A pure sine wave output produces an AC output that follows a nice smooth sine wave. You remember what a sine wave looks like from your high school trigonometry class, right? It's a nice smooth wave. This is what you will find in the electrical outlets of your home. But most inverters don't produce a pure sine wave. They produce a squared off rough simulation of a sine wave, a so-called modified sine wave. A pure sine wave requires more complex electronics to make, so inverters with pure sine wave are typically a bit more expensive. But pure sine waves are much better for sensitive electronics, like computers or monitors, and especially for appliances with motors in them. So the second major thing to consider when selecting an inverter is how much power you want from it. You can get inverters ranging anywhere from 50 watts to 3,000 watts or maybe even more. But when you install these inverters in your van and connect them to your van's 12-volt electrical system, this power will ultimately come from your van's alternator, which converts rotation of your vehicle's engine into electrical power. So how much power do you want to pull from your alternator? How much power can your alternator source, especially with other vehicle loads turned on like your headlights and air conditioning? So I chose to go with this high-quality inverter from VICTRON. It's a 375 watt unit with pure sine wave output. These are also available in much larger sizes, but I decided to go with just a 375 watt unit because I really don't want to put much load on my van's 30-year-old alternator, and frankly 375 watts is enough for my needs, especially since I'll be charging my battery bank in its so-called silent mode. Silent mode charges the battery bank more slowly. This is better for the longevity of the battery, and the battery bank can then charge without having to turn on its cooling fan, which makes it quieter. This unit also has a connection point here, which you can connect to the van's ignition circuit so that it knows when the van is running. Thus, the inverter will only draw power from the van while the van is running, which is a good way to make sure that I don't accidentally drain my van's battery. This is not a very common feature among inverters, and is another reason why I chose the VICTRON unit. Now, like most other inverters, it will also turn itself off if it senses that the van battery voltage has dropped below some threshold, and you can use that option to protect your van's battery if you're comfortable with that. But I like the assurance of using the ignition signal wire, so I'll show you how I installed that too. So here is a diagram for my installation. I have the VICTRON inverter here in the center, connected to my vehicle starter battery over here on the left through a red and a black power wire. These are 8-gauge copper stranded wires, about 10 feet long. The red wire passes through a 40 amp resettable breaker, which I will have up in the engine compartment. On the output of the inverter, I simply plug in my battery bank to the AC output of the inverter. I also have an 8-gauge chassis ground wire connecting chassis ground of the inverter to the vehicle body. Then I have a 16-gauge wire running to my cabin fuse box. I'm attaching that wire to position 3 in the cabin fuse box with a fuse tap. This position 3 is normally used for the cigarette lighter and turns on and off with the ignition. This will provide a signal to the inverter to inform it on when the ignition is on and off. If you're unfamiliar with a fuse tap is a device that lets you get 2 fuses into the position for a single fuse in a fuse box. The first fuse is the original fuse that was there in that position, and then you have a second new fuse that you can plug in here for your new signal wire. Okay, let's get to the actual installation. So I'm going to install the inverter here under my front passenger seat. There used to be an old 1990s CD changer down here, which I have chucked. So I'm going to make use of the same fasteners that are already on the floor down here to mount my inverter. I've made this aluminum plate, which has holes for those fasteners as well as holes for mounting my inverter. And then I'm going to run heavy gauge cables from the inverter under the floor and through the firewall at a point here where there's already a wire bundle coming through a rubber seal at the firewall. Once the cables are through the firewall, they will come up into the engine compartment here where I can attach them to the van's main battery. But alright, let's get going. So let's start by drilling a first hole in the firewall grommet. You can find the grommet here in the left footwell behind the glove box, which you'll need to remove to find it. Now, I've already checked where this wire harness goes on the other side of the firewall. Once the harness gets through the grommet, it goes straight up at the 12 o'clock position. It's important to know that so that I don't drill through the grommet and right into my van's wiring. You need to know what's on the other side of what you're drilling through. So, since the wire bundle goes straight up at 12 o'clock, I'm going to drill my new hole through the grommet for my power cable at the 3 o'clock position. So my drill bit avoids that wire harness when it punches through the grommet. So here I'm drilling the hole through the grommet at the 3 o'clock position. Now this 30-year-old grommet was actually quite stiff. I couldn't push the power wire directly through the grommet, so I decided to push an aluminum sleeve through the hole first. This will keep the grommet hole open while I push the length of the wire through it. Next, I positioned a wire hanger with a loop bent to the end of it over the end of the sleeve from the engine compartment side. Now from inside the vehicle, I can shove a pull string through the sleeve, meaning that the string also passes through the loop into the wire hanger. I can pull the string up through the engine compartment. Next, we'll pull the red power wire through from the engine compartment into the cabin. Now, I have already run 2 additional thermocouple wires through the same grommet hole, but they are not the topic of this video. I just wanted to point that out to explain why you'll see them here. So I secure the end of the wire to the pull string, first with a clove hitch knot, and then with duct tape. I use duct tape to taper down from the wire diameter to the diameter of the pull string for a smoother transition. Now it took some wiggling and jiggling and back and forth to get the end of the wire to turn the corner into the sleeve of the grommet. It probably would have been easier to pull the wire through in the opposite direction, but I eventually got it through. Okay, with the power wire through the grommet, I now route it to the location of the inverter under the front passenger seat. The wire can pass through an existing cable sleeve and under the carpet and under the plastic door sill. Now I will Dremel this area of the plastic door sill here to open up a notch with smooth edges for the wire to pass through. And I'll cover the wire with a split plastic protective conduit. This is just an initial rough routing at this point. Next, we'll terminate the end of the cable with a terminal ring by cutting into the insulation, flexing the wire to propagate the cut through the insulation, and then crimp the terminal ring on. Finally, we cover the crimp barrel with heat shrink insulation. Now, up in the engine compartment, we'll mount a 40 amp resettable fuse here close to the battery to complete the circuit. Here's a rough layout. By the way, I've put a link to all the components used in this video down in the video description if you're looking for all those details. So again, we'll strip the wire in by cutting halfway through the insulation, then flex the insulation to propagate the crack through all the way to the conductors, and then we can twist off the insulation slug. Then we'll make the waterproof connection to the first end of the fuse. For the short wire running between the battery and the fuse, first I'll strip and crimp a terminal lug on one end, just like before, which will connect to the battery. Then simply connect the other end to the fuse. By the way, it is best to make these hookups with the fuse in the open state until everything is hooked up to the inverter and you're ready to turn it on for the first time. I'll secure the fuse to the engine compartment here with zip ties a little bit later. Do make sure that the fuse can freely open and close without hanging up on anything in the engine compartment. And I'm going to hold off connecting to the battery until I have everything else fully installed. Next, I'm going to route my black power wire between the inverter under the passenger seat to the battery in the engine compartment through the same firewall grommet, just like I did with the red wire, except this time I'm making a hole in the grommet at the 9 o'clock position opposite the red wire. I'm also going to install 3/8 inch split protective conduit over these power wires. I'll secure the conduit with electrical tape at the ends. And I'm pushing the conduit as far down toward the firewall grommet as I can get it. Just work it down as far as practical. Finally, cut the conduit to length and secure it with more electrical tape. I also covered all the red wire in the engine compartment with plastic conduit in the same way. And then also covered both wires as they pass from under the plastic door sill to the area under the passenger seat. This required drilling a notch here in the door sill so that the wires can pass out from under it. Now, with the power wires routed, it's time to make hookup to the VICTRON inverter. I'm leaving the extra wire length on my red and black power wires for now so that I have the option to relocate the inverter later if I want to. First, I'm attaching a short piece of black wire to the chassis ground terminal on the inverter. Then I'm stripping and attaching the red and black power wires to the terminals on the inverter. Next, I'm removing this little jumper wire here, since I'm going to attach a signal wire from my ignition. Now I'm attaching a 16 gauge signal wire to the left terminal here. And finally, it's time to install the inverter under the seat. Now, there's still a lot of extra wire here, which could all be trimmed down once I'm happy with this location, but for now I'm just coiling it and securing it under the seat. Make sure that it doesn't snag up on the seat. Here's what my final installation looks like for now, before my final trimming of the wires. You can see that the seat release cable barely clears the upper right corner of the inverter. And now the AC cable from my battery bank will eventually plug in here on the side of the box. I didn't capture what I did with the other end of the chassis ground wire, but you can see it connected here, where I drilled and tapped a 1/4 inch threaded hole in the floor of my van and then bolted the end of the wire with a terminal ring down here. Note that the finish has been sanded off the floor to provide good electrical contacts. Now, let's connect your signal wire to the ignition. I didn't capture this on video as I did the work, but I routed that 16 gauge wire under the floor carpets to the fuse panel here under the steering wheel and connected it to the panel with a fuse tab. I'm using fuse position 3, which is the fuse for the cigarette lighter, which is only on while the ignition is turned on. Thus my inverter will only be on when the ignition is on, which should prevent discharge of my van's battery. Okay, it's finally time to power up. I've plugged the night light here into the AC output of the inverter just to visually show when the inverter is powered on. So first I'll close the fuse on the engine compartment. This supplies 12 volts to the inverter. Next I'll turn on the ignition, which signals the inverter that the ignition is on. And finally, I'll hit the power switch on the inverter. And voila, we have power at the output. Okay, so I've got my battery bank plugged into the inverter here now. And you can see here that when the inverter turns on, we get about 260 watts into the battery bank. Now the battery bank is not drawing the full 375 watt capability out of the inverter because I've got that battery bank in that so-called silent charging mode, as I explained earlier. So there you go. That's how I installed this VICTRON inverter in my van to charge the battery bank on board. Hope you found this useful. If you did, check out some of the other camper van conversion videos on my YouTube channel here. And thank you for watching, and have yourself a fantastic day.